Hi friends, I am Vishnu Sukumaran, second year postgraduate student in statistics from the Department of Statistics, Ramla College, Moatura. So, I am here today to introduce to you one of the most useful statistical methods used in data analysis today, that is the multidimensional scaling. In many situations, we come across many multidimensional data or data having multiple aspects. But the fact is that most of us are unaware of these multiple aspects of the data. In this session, I am trying to depict the multidimensional scaling mechanism. What is multidimensional scaling? Multidimensional scaling is a visual representation of distances or dissimilarities between sets of objects. Objects can be colors, faces, map coordinates, political persuasion, or any kind of real or conceptual stimuli. Objects that are more similar or have shorter distances are closer together on the graph than objects that are less similar or have longer distances. As well as interpreting dissimilarities as distances on a graph, multidimensional scaling can also serve as a dimension reduction technique for high dimensional data. From a non-technical point of view, the purpose of multidimensional scaling is to provide a visual representation of the pattern of proximities, that is, similarities or distances among a set of objects. The term scaling comes from psychometrics, where abstract concepts are assigned numbers according to rule. For example, you may want to quantify a person's attitude to global warming. You could assign a 1 to doesn't believe in global warming, or 10 to those who firmly believes in global warming, and a scale of 2 to 9 for attitudes in between. You can also think of scaling as the fact that you are essentially scaling down the data, that is, making it simpler by creating lower dimensional data. Data that is scaled down in dimension keeps similar properties. For example, two data points that are close together in high dimensional space will also be close together in low dimensional. The multidimensional part is due to the fact that you aren't limited to two-dimensional graphs or data. Three-dimensional, four-dimensional, and higher plots are also possible. So, while doing multidimensional analysis, there should be only a 20% of compromise in actual information. So, I have already mentioned about the Human Development Index, which you are all familiar. For example, let us familiarize with the HDI or Human Development Index first. The Human Development Index HDI is a summary measure of average achievement in key dimensions of human development. A long and healthy life, being acknowledgeable and have a decent standard of living. The HDI is the geometric mean of normalized indices for each of the three dimensions. The health aspect of the HDI is measured by the life expectancy as calculated at the time of birth in each country, normalized so that this component is equal to 0 when life expectancy is 20 and equal to 1 when life expectancy is 85, that is high. Education is measured on two levels: the mean years of schooling for residents of a country and the expected years of schooling that a child has at the average age for studying school. These are each separately normalized so that 15 mean years of schooling equals 1 and 18 years of expected schooling equal 1, and a simple mean of the two is calculated. The next one, the metric chosen to represent the standard of living is GNI per capita based on purchasing power parity or PPP, a common metric used to reflect average income. The standard of living is normalized so that it is equal to 1 when GNI per capita is $75,000 and equal to 0 when GNI per capita is $100. The final Human Development Index score for each country is calculated as the geometric mean of the three components by taking the cube root of the product of the normalized component scores. So here is what I was trying to explain. The Human Development Index may seem to be a particular or a single value, but it is the aggregate of many scores. It is an index which is the combined aggregate of many factors like education, the standard of living, the national income, and many such things. So the Human Development Index has got multiple dimensions and is an aggregate measure of all these scores. In real world data, we come across many a number of such multi-dimensional data which are reduced to two-dimensional data for better understanding. Let us consider the case of the World Happiness Index, which has multiple dimensions such as freedom, social support, perception to correction, generosity, etc. Our aim is to reduce the multiple dimensions so as to find out which countries are alike in terms of the happiness index. So, the World Happiness Index report is prepared by the United Nations Development Program. This is what the report of 2019 looks like. And when we take a look at this, we may find that the Scandinavian countries are at the top of the table. Finland, Norway, Denmark, Iceland, Switzerland, and many such European countries are in the top. And let us take a look at the factors that influence or which determine the happiness index. We have the overall or aggregate score of happiness index here, and the factors which influence them are, first of all, we have GDP per capita, and then social support, health life expectancy, freedom of make life choices, generosity, perception of corruption. And these are the factors which make up the human happiness index. And when we take a look at this, I have prepared or I have taken the top 20 countries, then the countries which are ranked from 54 to 73, then again 120 to 139. And look where our country India is. India is at the 133rd position. So India has to perform better in the field of happiness. We have a better or growing economy in the section of the developing nations, but in the list of happiness index we are far away or far behind many such countries. And here we, as I have mentioned, we have many indices or many factors which compute or which make up the happiness index. GDP, social support, health life expectancy, freedom to make life choices, generosity, corruption perception, and we have multiple dimensions. And how do we represent them in a single graph? When we what we see or in many situations we may be able to plot two-dimensional or three-dimensional data, but it is not like that. It is here we have more than three. Here we have multiple dimensions. So the task or the problem with us is to reduce the data to a single dimension. So that is what multidimensional scaling has to do with. So this is what the multidimensional scaled plot looks like. Here we have the data is reduced to two dimensions. From we having 6 dimensions, we reduce the data to one dimension, and we have a cluster of points where the countries, we have the rank of the countries, and they are and they cluster around the countries which are alike in terms of the happiness index are clustered around. So these are the basic concepts of multidimensional scaling. The concept of multidimensional scaling is simple. We have many dimensions on a single data and we reduce it to two dimensions for better understanding. So that's all for this session. Thank you for watching.